that's my face. Oh no, won't let me click on my face. Strong start. Alright. Let's go over your guys' problems from your review sheet. Alright, number 2 is asking you to find Amram. The equation was 4x minus x to the third. Alright, so the first thing you have to do is you have to graph it, right? So you would have drawn this graph here, this black line. Alright? And then since we're using LRAM with sub-intervals of a half, and it told you that in the question. So we go over here and we start at 0. We went over. That's a half. We go over at 1 and go over. And then 1.5 because that's halfway between 1 and 2, right? And they're sub-intervals of 1/2. Little dot. And you go over. Oh, that was terrible. Okay. So we have our 4 rectangles, sub-interval of 1/2. So if each one's a half, we do 1/2, right? 1/2 times our height of our first rectangle, which is obviously 0, plus the height of our next rectangle, which they call 15/8. Where did they get that 15/8? Good question. You take your 1/2 and you plug it into your original equation, because that's the height of that rectangle is what you get when you plug it into your original equation. Plus, they got 3. How'd they get 3? You got 4 times 1 minus 1 to the third, right? Again, that's because that gives us the height of that third rectangle. And the last one, they have 21/8, okay? And that's because you go 4 times 1.5 minus 1.5 to the third. That's it. That's all there is to it on that one. So I'll pause this for a second and check on something. Alright, my Moe pen died, so I'm going to try to do this with a keyboard for a little bit. So bear with me. This is going to be awful. Alright? But hopefully that pen will charge. I don't know, it took me like 10 minutes to get to... Alright. Alright, so when you plug that in, it's going to get 3.75. Ta-da! Alright, I got it with my face again. This is about a hot mess. Like I haven't done this in like a year. Alright, next one. Asked you to do Amram. Okay? Now for Amram, it's the midpoint between the two, right? So, we're still using a half. Writing with a keyboard. Okay, so we get the point between 0 and a half, which is 1/4. And we pick a point between 1/2 and 1, which is 3/4 for my point. And I draw them across and then down. And I pick a point between 1 and 1/2, which is 1.25. And I pick my point and I go down. Okay? So, this is 1/4, 1 or 3/4, 0.75, 1.25, 1.75. Take those numbers, those x values, and you're plugging them into your original equation, 4x minus x to the third. So like 63 or 64, that is 1/4, or 4 times 1/4 minus 1/4 to the third power. 165 or 64, that's 3/4. 4 times 3/4 minus 3/4 to the third power. Okay? And then you just plug in your formula. 1/2 is your height of each one. Alright? That's it. That's all there is to it, I guess. Alright? If you have questions on that one, come back and ask me. We'll do another one of these in class. Right? Alright, and then RM, you do the exact same way as LRAM. You start from the right and you go over. Start from the right and go over. Start from the right and go over. Start from the right and go over. Okay? We're still using our half subintervals. There's 4 rectangles. 2 over 4, our range or number of rectangles, is 1/2. So the height of each one is 1/2. Right? So we get the 1/2. That 15/8 comes from when we plug in a half to your original equation. You can see that in number 2. 3 comes from when we plug in 1. 21 over 8 comes from when we plug in 1/2. When you plug in 2, you get 0. You're actually going to find this is exactly the same as algebra. It's not always true. Don't assume that. You know what happens when you assume. Please check your work. Again, plug your points into your original. I wish I had my okay. The next one we're using Trapezoid Rule. I'm definitely going to grab my movie on this one, but I'm just going to tell you why they did what they did. So a shortcut to Trapezoid Rule, I gave you this formula earlier, is it's 1/2, or it's the average of your LRAM and your RRAM. So 1/2 LRAM plus RRAM. And so we have LRAM and RRAM from our previous problem. The averages, of course, can be equal to what they are, which is kind of a neat result on this one. Okay, so I'm going to pause this and see if I don't have any light in my movie to try to do this. Alright, it's flashing, so I'll be brief. Our trapezoid rule is as follows. It's our height over 2 times 1 times our first base, so it's going to be 1 times 0 in this one, plus 2 times our next one, our next height, and that's at 1/2, right? And we have that from previous problems. We get that from plugging that in to our original equation. It looks like it's 15 over 8. Plus 2 times, well, what do we get when we plug in 1? 4 times 1 is 4, minus 1 is 3. Plus 2 times when we plug in 1.5. We're plugging 1.5 into the original equation. And we did that before and we got 21 over 8. Or some decimal. Because this is just the height at that point. Plus our last point is 0 again, 1 times 0. Okay, and then if you do it this way, you plug that in, you should end up getting 3.75. Hopefully that works out for you. I'm going to say it for the 1,000th time. You can't see where I'm pointing. We get these values by plugging, like this is f of 1. Whoa, 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 whoa. That. Whoa, whoa, whoa. F of 1/2. This is f of 1. This was f. This was f of 1.5. Alright? That's how we got those. I gotta pause it again. I'm gonna go try to go no Moby again. This is going to be terrible. Oh, I should just wait for a charge. Alright. So then to find the actual area of the curve, we have to find the integral. We have to integrate it. So if we look before our graph, we went from 0 to 2. That's what enclosed that space. Okay? So we have to integrate this beast. I gotta grab my Moby again. Change my mind. We're gonna do this one when I get my Moby kind of back. That's more than that. Like right there, right there. Oh, man, I am so out of practice in this. It is ridiculous. Okay. Let's take a look at number 9 for right now. Number 9, there is the rule with the integration. If you switch your A and your B, your top and your bottom, all you do is you take the negative of your integral and it's to work. So A is true. It's just a rule you guys gotta know. Live it, love it, learn it. Any other else you guys want to do too, that's fine. B is also true because remember, if you're integrating in respect to the same variable with the same dimensions, the same A and B, you can just add together integrals. It's area. It's like area of a triangle plus area of a rectangle is the area of the whole house. The whole house. B is true. C is not true, and this one's a little bit more hard to explain. It's not true because if you actually break down the integrations, because remember you can do that, right? Because if we know the area from -2 to 5, we can split that up into -2 to 2 and from 2 to 5. Okay, and we know when we add those up, we get 7. And the integration of g of x is 2. So 7 is bigger than 2. Alright? Right? Isn't it? Yeah, 7's bigger than 2. Alright, I'm not gonna spend a whole lot of time on this one. What you're basically doing is, where's my book? Make sure that I'm looking at these questions right. On 12, it starts off with saying from 0 to 10, right? From 0 to 10. If you read the top of the problem, it says from interval 0 to 10. And that's why all these go from 0 to 10. All A through E. And then the rest of it is, wherever you see C of K, you change that to an X. And then wherever you see a delta X, the triangle X, you change that to DX. So what you're actually doing is you're taking that sigma. Sigma is when you add up all the pieces. That delta X is the height of your rectangle. You're making an infinite amount of rectangles. And that's what integration is. You're taking all those rectangles, you're making them infinitely small. You're pretty much doing LRM and RM, MRM, whatever you want to call it. You get the actual area. Okay? So I want you to look at this. Let it soak into your brain. Osmosis. That's not osmosis, it's water. Sorry guys, I keep skipping around all over the place. I'm doing all the ones I don't need a pen for. Alright? So this next one, go all the way to the end, 56. This is one though I think you guys are fairly confident on. We're using our trapezoid rule, right? So trapezoid rule says height over 2, and there's 20 meters, or 20, not 20 meters, 20 feet between each measurement, right? So that's how we get 20 over 2. And then remember, the first and last measurement we only use once. And all the ones in the middle we use twice. Alright? So that's where we get 146 plus 2 times 112 plus 2. You guys can look at that and see it. You should have gotten 8,030 feet squared. But that's not the answer. Not yet. So the next thing you do is you times that by 5. You times it by 5 because the average depth, the average deepness, is that word, average depth was 5 feet. Which is good because I can't swim. And I'm 6 feet tall, so I might not drown in it. So that's good. But now that would have given you some really big number. The secret here, and I won't make you do this on test. So if you got whatever that is, that's all right. So you have to divide by 27 because a cubic yard is 3 by 3 by 3. So it's 27 cubic feet. So that's how they got 1,500. But if you can do this jazz, you should be pretty well set for the test. I'm actually going to publish this one. I'm going to make a second video called the Moby one, so that way, Moby ones. Alright, so